I also got the stops in today, which have it limited well. And the other thing that I did was a bit of a test and a bit of an improvement. Not only is it pinned there just that far down the lever arm, ideally it would be pinned lower, but the weight pack gets in our way internally, and externally we've got the mast on the outside in the way on the side that you would ideally lock this up and unlock it, because this is facing the audience when we need the utility or the functionality of the tipping ship. So even though I could re-drill and pin way low out here, this is going to kind of be behind. I mean, I literally trimmed these corners back just to bring that form of the ship's bow under as much as possible to get it to have that correct shape. So we don't have any room for anybody to be here and to pull this pin. So that in there is going to have to go away. It's not going to work that way. Not to mention we're pinching it like we said. So for now it's in there, and I added some latches over there, and I've already got an incredible amount. In fact, I'll go right up there. I've done this already, but I never did it on video. So we're this high because the stair pieces that we had that were ready to go stepped up to this level. But now we're out here. It's a little creaky, and it washes laterally a little bit, like that. But we're a ship on the ocean, and so I'm hoping that that's forgivable. Not to mention we don't have to block a bunch of activity here. Try to get back to this. Okay. What did I do? I put in some of these pole barn door latches that I use a lot because they cam lock. They tighten up when you throw them. They're relatively cheap, 20 bucks each, and they're adjustable and nice and really heavy duty. They're for a big sliding panel, 14 feet high, 10 or 12 feet wide door on a pole barn in the whipping wind. They're supposed to lock that situation down. So they're a really nice heavy duty application. So I put this is the pendulum that swings by. So I put a hole here, and you've got all this looseness, to get everything in, and then you just pull it over, and it draws this in against pulling and pushing. I've got one on the other side. So together, they need to be adjusted, and they're fighting each other. But it is the type of thing that we'll be able to unlock. You just need to get this out of there as well when there's dynamic loading happening with people moving around on the deck. So I'm not completely sure if that's a solution yet either. Although, what we could do is create a feature out here. And I was going to say, have a rubber band. I don't want to be pulling that out prematurely, so everything has to be dialed, and that starts to become the problem with wood. Wood's got a lot of pros in construction, but one of the cons is it can kind of change. And so temperature, humidity, and being worn in. I was going to say, if it soon as it was released, it went zoop and wanted to come out, that would be better. However, once we've pulled it in tightly, I'm actually able to pull that out, because even though there's pressure right there, we come off of it. So if I were to thread this in, and then I need to loosen the lock nut, but we painted this before, so it's going to take some test and tune, and I'm not sure it's the answer yet. You've also just got this little bit of thickness, this little bit of wood, after all of this construction, this little bit of wood, if it could split, tear off of there due to the leverage out here from the weight, then you're in a pickle once again. I would have preferred to put a nice heavy duty screw eye in so that the loop was facing us here, and then drop this in at 90 degrees so the hook falls into the screw eye, and then the switch pulls that in tightly. But the screw eye is steel, and it's also threaded into the edge of this, and pulling on it axially is actually wildly stronger and not as hard on the wood as it is cutting a hole in it and trying to rip the grain apart. However, taking this thing to 90 degrees so that the hook could fall into a loop like that puts it in the space here where the pendulum swings, and this has to be planar. In fact, that little tab is hanging out. unused. I used these 2 screws here, and these would be replaced with those really heavy lag replacements. And in fact, in the event this is going to work for us, I was just testing it with construction screws here. However, if it was going to, I'm going to have to cut that off with a grinder just to make it flush here and modify it forever. And it's really not ideal because the pinion is in the center of this 3-bolt layout, and then all of a sudden I've got 2 bolts on one far side of the center, and I haven't got something on the other side. So, you know, things start to become really annoying. Could I hammer it around the corner and try to smash it into the wood so that it is flush? Yeah, then I could add a screw, but the screw head's thickness is back in the way again. So I could migrate the whole thing over enough and notch it out to bend this over in the vise or on an anvil, and then drop it in and have room for the thickness of it and the head going sideways into the lumber. Once again, I don't know. Right now, both of those employed with that pin. So attaching this so much farther down than that pin over there, this lever arm is effectively twice as long against that one in this application. And adding these to the pin has made this even more rigid and stronger. So I'm on the right track, but I'm not there yet. So TBC, to be continued. Well, I like this method of prototyping, sort of starting with scale material, so I know what I'm talking for feasibility, and I'm really wrapping my brain around the method by which I intend to make something in real life, or the real thing. So that being said, I had 2 sheets of 4x8 material in a 1/6 scale, so that's 12 inches by 24 inches. It's a real nice size. And you can sort of just back up and just pretend you're farther away and really look at something as though it's really there in a lot of cases. Like I can pretend I'm in the house and I'm looking up at this thing and I get a little over the top and into the other side. Jam, visual line of sight that I hope that I get when I'm on stage. Sorry, sometimes I want to throw away the negative and sometimes I want to keep it so I know what I took away. So I'm just being careful of that. Might be such a thing. These aren't, not sure. Anyway, so if I were to make the sides of the dinghy or the little boat for Kiss the Girl from maximum tip to tip out of a 8-foot long piece of sheet good material, I made the one and then I flipped and traced to the other, so they're completely symmetrical, and the changes I made to them as I developed the profile of this, or the look of this thing, I made symmetrically to them. But this is the largest possible thing I can get out of a full 4x8 sheet, which is what's still on the bottom of this, believe it or not. So that, being curved, and I went about it this way on purpose, being curved and flared out, etc., and undercut at the back just a little bit. I'd actually rather that the bow was undercut and the stern maybe just a little bit more, to sort of truncate that. Maybe not, who knows. But you can see that at this scale, I've got over a foot left of this material, which is 3 inches, and actually it's nearly 2 feet. So it's a 6-foot long boat at that point, maybe a little longer due to at the top. Do we get to 7? Not, yeah. So I don't think it's large enough. I think that this needs to go from here to the point, needs to go to 8 feet, and thereby we have that much more, and we could get to, actually the real constraint is going to be the 4-foot width, although I think we've got a 6 inches there and 6 inches there, almost anyway, maybe 5 inches, but we could gain an overall foot of width, which is twice what we're looking to gain in length, so we can, we probably can't quite get to the full length. That's okay. I think we need to. So we need to make sides that are longer than this. And even though they came out of either side of the same sheet, I think that I intended to make these from Luan. It'll do that bend, no problem. Going thicker I would only do because it's going to be harder to bend, but it might be like more effective to fasten through. But basically, I'm going to need a block inside the bow and a block at these inside corners to the transom at the very least. And from the 3/4 inch plywood base to the Luan side, I'm going to need some kind of curving block here. And I actually planned on trying to cut rip a stick with an angle on the side and have it bend, and that was where I was going to start, actually, was to actually bend it on a 3/4 inch sheet of plywood and see the bend that it would do in this regard to maximize the total length. And then I know that when I get to making that piece and trying to put it in, it will even do this bend without breaking. So that's actually not a bad place to start. Since I know I want to get out to the full sheet if I possibly could, I could start by trying to cut that, not a gunnel, but it would be a block that has to curve and has an angle on it, and it's close enough to put like a bead of glue on the side of the boat, a bead of glue on the 3/4 inch plywood, smush it into the corner, and then screw it down to the plywood bottom and go out and screw it, just hold the Luan into that block from the outside would be the final goal there. And so, since it's just Luan and going thicker isn't going to come close to being able to actually meaningfully fasten, I can just use Luan with confidence. And then on the top edge of it, I'll just slap some of the ye old pipe insulation foam for a gunnel. It's already slit. It'll go right into the edge, and it'll give it a substantial lip that will always make you feel like the thickness of the wall of the bolt is substantial. It's just a big fat curve going over the top. You'll never be able to know that it's just a Luan side here. And I think it'll really make this thing incredible for hopefully a quick and easy, effective process. So what does that mean about these sides? I think I've got to get 2 sheets of Luan, line up the long aspect, but slide them, past one another by a good however much, frankly. And I should just go exactly to what I need. And where they overlap, I'm going to have to glue them together and, with roll some wood glue out on it, clamp it overnight, and hope that area flexes without a problem. So I assume that it'll be all right, but there's a chance I use a different type of adhesive there. But I have to actually make that material. Cardboard, believe it or not, would work okay, double layer cardboard, but it's going to be the same story of not having enough length. Even you can get it in 4x8 sheets, but nothing much larger without a lot of extra trouble. So I got to make an extra long set of sheets. I think that starts by just making more cardboard here and trying to get a reasonable boat right onto this 4x8 sheet additionally, but go as far as I can to here and just see if I can get the bow to tip out a little bit more and basically just rebuild it here. I put a center line down this sheet. I put 1 foot marks across the back, and at the middle, at 12 inches down it, or halfway, I put 12-inch marks here so I could symmetrically go to, actually those are 4 inches each. So I could go to 8 inches on either side at that location. I went to a full foot at either side here, and I have, symmetrical components. And if I put them down in the same place, I stay, I have a pretty symmetrical thing. So I'm going to continue along those lines. I'm going to start probably a little bit wider and go much farther and try to tip that out and have a relationship between the two hull shapes on this same one sheet for discussion purposes. And then we'll make ourselves a decision. Well, believe it or not, I went to 10 feet for the next pieces, thinking that would be an easy enough double Luan sheet to create. However, that was only going to get us roughly, you can see, to about here. So to get that shortest aspect, roughly, to utilize the whole 8-foot sheet, I had to get even longer with it, and it actually became a piece that the curve on the bottom that helps you to do the floor shape, the curve on the top necks in on this one and this one. But actually, by the time I got to here, it's actually a positive arch from the tip of the bow to the tip of the stern. That piece has actually got a positive arch. So that being said, I think that's going to be the case of the final piece. However, I actually I prefer more sidewall, even though we're going to have a low angle from the house. Actually, the first angle is kind of like level with your eye. And so I just want to just like hide as much as I can in this thing. And I prefer the silhouette of the inner hull here. The front, or the outer one, the front is at the same height roughly at the bow. It was the point. The tip was supposed to be roughly at the same elevation, but in fact it sits forward. It ends up being shorter, and so I think we actually need, so I don't think that carrying this up is the right answer. I think that somewhere in between, maybe more accurately at that same height. And then it needs to be filled to here, dip to that same point where they cross here, but then stay below and end on the transom at the same place where this is a bit higher than the transom. And so I had to hold it here enough to see that. I've got to transport it. I've only glued to this point here. The rest of this, if I unclipped it, would come off. And so I could measure it and study it and, make my point that I think we need to utilize another sheet of Luan, because I can still get both sides of the hull out of a 4-foot width. And so that's an aspect of it too. And so I think we're going to take this in and discuss this. I think if we're going to build a boat at all, it could be on wheels this way. We put one pot in the front and maybe one on either side toward the back, but not exactly at the back, and try to get that to be a stable kind of tripod footprint. And a wider tripod in a larger footprint is a more stable thing. And I don't think that people, you got to imagine two people here. The boat's going to look full if we build it at this larger size. I think it would have been like clown boat looking if we'd have built it at the smaller size. So that being said, I'll take these with me and we'll have that discussion along with some others, and we got to keep moving here today. So if we go into my portfolio all the way back to one of the first shows that I built, Seussical, and you can see the other shows in there along with the rest of my work, just FYI. But we go into Seussical, and there's something tickling the back of my brain. Here's the I bothered to draw the framing, and in orange I had the sheets of Luan, minimum amount of framing to support it, so I could get the Luan put together and up there and project the Whoville onto it. But more importantly, the Horton tree branch that has to be propped up from his fat elephant butt sitting on the nest. But then I wanted it to be bent up higher, significantly higher, for Maisie, the bird, up in this sort of position when she's sitting in it. So I had this laminated plywood branch on this laminated plywood trunk, and it has a counterweight down here that was going to be turned into like the little bit of one of these fluffy things here, all in keeping with the book. And I had like a saucer sled. It was cut out for that, and that was back when I was content with these already existing trucks. And putting a pivot into the framing, into that crispy old framing. Anyway, Whoville turned out, one of the things that always kills me is again, here's with the truck, starting with a couple of trucks screwed together and then building on top of them. Hate doing that. It was like the first and last year I ever did it that way. And for whatever reason, the door opening, like instead of coming down to it within an inch of the floor, it stopped short of the truck, but it just was hovering in space. It was weird. So anyway, cool, but also weird. But what I'm looking for is in the final product, I hid behind these bushes, and here's the AV guy pushing it down for me. I didn't have a lot of help with this. I wasn't shooting video, but it could be pinned to support someone's weight up there with a big heavy draw pin, or you could pull the pin and someone's weight would be enough to push this down. And that worked because in the bushes right here, what you doing in them bushes? There's a gas spring. It's got a eyelet and a double-sided bracket on both ends, and the compression pressure in pounds, I think, was in the hundreds of pounds, because I mean, from this point, you've got, say, a 200-pound person out on a lever arm that's 3 or 4 times as long as the lever arm between the pivot plane and the end of this thing. So it's 3 or 4 times the weight or the force. So you had 3 or 4 times the weight of a person. And I think I got 2 or 3 of these from McMaster Car and just fit them in and tried to find one, you know, that did what we needed. Ultimately, I did. Spray painted it black and ran it. So we've got that problem this year, I think, with this tipping ship. I think that I counterweighted it to begin with to try to combat how significantly the changing loads of people walking up and down, back and forth, or reacting to the tipping of this platform, multiple people's weight, would have it slamming and crashing around too quickly. Basically, the counterweight was meant to resist that. I think we're going to end up needing gas struts to resist it as well, which would mean, you know, it'd be like taking up the hatch at the back of your car and putting the kid on there, and the kid can jump and it would, you know, move up and down, but to a certain extent, a certain child or whatever, not that this is a safe thing to do, but just to visualize it, isn't enough force to close it, which of course mom and dad can close it. So we got to find something that resists the changing weight of half as many people on one side of that pivot to everybody moving to that side of the pivot, and it not just closing that down completely necessarily, or maybe only just closing it down. So we've got a lot of variables. Again, no finite element analysis happening, but I did go into the model and I moved it to show, and I haven't even done this perfectly, but I tipped it down to roughly where the stops that I installed yesterday are, putting it, and then I put some sketch lines in here. You can see them in red, and you can see that their dimension, their elevation, 18 1/4 from this surface is the same. And so ostensibly, if I were to find what looks to me like a lower half, first third of this overall length, and at full extension, it's not quite 90 degrees to this, right? That's not 90 degrees, it's acute. And full compression, it's just a touch over obtuse, and that's just a touch acute. I think that's a logical place to start. And so around 40 inches at extension and 22 in compression, because I took that to the same point. It went to the inside corner of the structural end of the floor system, and I did the same thing over here. So of course the bracket that I'm talking about placing would be here. So we're being a little loose with this. We're playing a little jazz, but like between 40 and 22, you know, what are my options? So I go into McMaster and I start right out with the extended length of 30 or greater, which reduces what I'm able to even, you know, bother to have to look at. The stroke length, I don't think I specified. Yeah, 15 to 19.9. I don't think I need greater than 20 inches according to this in terms of stroke length, although that would be one of the things that I check here now that I've drilled in through this. And then I've got some choices. The add a fitting gas spring is what we're going to need, where it's just got a threaded end, so I can buy the eyelet and the brackets and heavy duty brackets and all of that. So we're going to need an add a fitting spring. See, most of them come supplied with a ball joint, which we don't want to be pushing sideways on the axial joint with this situation here. I don't think we need to worry like that, and it also adds a lot of structural weakness that we don't want. Because we're working actually with a lot of force here as far as he's concerned. I'm lucky to have these at my disposal, basically. So add a fitting would be where we started, and these grow in terms of extension length. So we get up to 34 right here, which isn't quite enough. And that's got an 825-pound compression force, not rated for cycles. And I guess it doesn't give an extension force. Weird. We don't need corrosion resistant, although I just glanced at it to see that the choice, it's just stainless. It's 316, I guess. But extension length, it's 34 again, which is getting closer to what I needed. And the forces you can choose them down here. But they're very, relatively cost effective for what we're getting here. You get up to 500 or so extension force, but that's not compression force. And extension force, so compression force is normally a lot greater. So the force to extend, how do I want to show that here? We get into it here. So corrosion resistant, reducible. So you can bleed off. You can get it wildly too strong. So like a compression force of 866 pounds. But then you can bleed that pressure off and dial it in. You can only go in one direction. You can't refill it. And the problem is that the regulator kit that you need, just for greater than 300 pounds, but for the 200 to 300 pound gas range, that's where the price is. Over $400 for those regulators, when the strut themselves less than 200 here. And actually this one is over 200. Oh, this rod protector, I was glancing at that. So the rod isn't a bad totally awful cost, but we just can't basically, it's cost prohibitive for us to get that regulator, which is just going to look like this and allow you to safely deal with the pressures that we're talking about in the thousands of PSI, I assume. So you got to have a robust construction there. So the reducible force, I don't think any of that is going to be in our budget. And the corrosion resistant add a fitting, we get to 34 here. I don't think nothing needs to be corrosion resistant is the thing. So, you can get up to a 550 extension force, which might be what we need. It doesn't note compression force, or the add a fitting, it gets up to like 825, but that's compression. So I probably have to snag a few of these. I'm going to have to look at what's available after 20 inches of stroke length. Maybe I'll uncheck that just to see what we're looking at here. Can't use those. Can't use any of these. Yeah, there's a lot more ball end. The add a fitting gas springs, do they go up 34? Extension force 18, that's nothing. Corrosion resistant add a fitting, those are add a fitting, but there's 34. You can still have the same options as before. Reducible and back to ball joints and stuff. So roughly the same thing. So you got to figure if we're going to put the full-blown 6 people up here, if you've got 600 pounds on one side up to 1,200 pounds on the other side. Let's say it's safe to say between 500 and 1,000 pounds that we're compression force at any given time here. So I think that we need to start with these that are hanging out at the 550 extension force, given that compression force is given somewhere here. Where are we looking here? These are corrosion resistant reducible force. No, we need just to add a fitting. Here, extension length, compression force. Oh, they're telling it here. So 550 pounds extension force. They changed the convention to the way that the information is laid out. 550, which is the bottommost one, extension. Does it give compression force? Yeah, right here. 825. So that's the relationship. I was trying to show this more cleanly, but 550 extension to an 825 compression. That's probably what the area of the range that we need. And again, 34 is quite a bit shorter than I had hoped, but and then compressed length is 18. It'll just have to exist. That's the problem though here, see, because I can't even get to 34 from this block. You start to find out, if I'm trying to sketch from here and I'm watching this shaded box with my overall length, the shortest that I can make it is that 38.122 or something right there, and then we start growing it. So I can't actually go to that block with some of these. So I'm either going to have to create framing inboard of that, which I'd rather not do, but it would be a possibility. And there's various things here. When you're pushing, there's just a lot of stuff at play. We've got to be a bit of an over-engineer when we pick this stuff out. And we've got hundreds of dollars that we're utilizing here, so we got to be careful. We're going to send stuff back that we don't use. But we may have to get a few things in to test and tune it. Anyway, I just wanted to talk a little bit about that. And that's where those things came from, is sitting here scratching my head doing this. And I've got to get the DXF of the ship's wheel to the CNC machine as well. So, all right, stay tuned. So this is the bones of that ship, the bow coming toward us. And I'm just trying to break up what we've been looking at for this whole time, for the most part, with those big pieces of cardboard that we ran into right in the hallway. They got 2 big screen TVs, so that's one box, and then I have another box, the exact same, which is going to be hugely helpful because of the, amount of cardboard we don't have to buy right to start with. So I expect to use it for this part, I believe. I'm just trying to understand how much I need to close the stairs in, and as well as see those pieces that are either side of that roof that we made for Shrek, for Fiona's tower. It was actually upside down. It flew in from above. They're hull shaped. There was more there than the outside of the stairs is just flat. There's a lot there already. Even that point as it like disappears and you see a bit of the first step, I think it's artfully a transition that, it just kind of makes it disappear. It's not clumsy. That little tip like kicks the body line out a little bit, and it gives it that truncated undercut shape even more so, even if I've tipped those. So they're hanging there from tape. What am I getting at? I thought if I made the edges of them broken, when the pieces rolled out and the edges of this hull were broken, the silhouette against the cyc would be broken pieces of a ship, floating away or whatever as it's tipping around. But the problem is going to be that the stairs is still behind that. There's not going to be the broken silhouette shape happening. And I don't know if there's any value now that I've cut it like that. Basically, I don't think there's any value to having cut it like that. So I'm sitting here thinking, that I wish I hadn't done it. My intention was to make the edges of this cardboard come over and lay against that and be a broken shape, but then to paint and finish the boards of the ship right through there, so when the stairs and stuff are buckled onto position and everything like that, everything kind of just lives together, and the edge is pointed away from everybody who's looking at it, so altogether disappears. However, I can't bring the broken edge up past the plane of this, or really it's the plane of that, because the tipping ship has to happen through here. So I can't bring it way up to where you would get any value out of the silhouette. In the end, I'm basically kind of frustrated that I did this. And I did think about this, but I figured the only way to really figure it out was to do as much as I've already done. The other thing is I need to be able to tip these back and forth and come up with whatever this angle is going to be and how far in it needs to sit, because if we were to sit these up vertically, they're going to be additive. If I brought this corner out to here as we've been doing, everybody wanted to bring that out, which makes some sense until you realize that you want this to be undercut like a hull. That's going to be one of the downfalls of most of what people would make on stage for something like this. They can get the footprint to be boat shaped and even squish the hull in, but getting it to cut under extremely enough to look more boat like from the house, that's where I'm trying to be a cut above here. So we've got it tipped out, and thereby when you come in flush right here, if you're tipping out that much, that pushes the stair over. So we got to figure out some amount that we're starting, got to figure out some angle, build a triangular addition to the end, or that angle addition to the end of the stairs, so it comes in and locks in there and attaches nicely. And then I can continue with the functionality of it and start, continue to think about how to doll it up. I needed to see what these were going to add and how much they were going to influence the stair location. So I had to cut it in half. I guess I might have gotten away without cutting it, but anyway, I did it already. So long story short, what can I do with it now? To remedy that situation, I don't know that it's going to be all that much of a problem. We'll come up with something, but I just wanted to mention that. And then this is tipping out from basically the minimum to a little past what I had for plywood sheets. Actually, go right up there and look. I think I want it to tip out a bit more than this. But in general, I'm pleased with what we got going on so far. This is way more spongy now without the locks on the inside. The movement that we're getting right here, see that? That's what we got to lose. Got to limit that. So the safety pin is in it, but the lock, I had to move it so that we could tip today, and this tab was in the way, so I had to pop that off so we could do some practice work. So I have to continue to develop that a bit better. And without turning everything around here, I think that the set is starting to look cool and ship-like. These, I kind of like how inclusive they are. Again, it's an interesting choice instead of just I mean, what do? Flat plumb edge, broken, jagged edges. It's a bit extreme, you know, or tip it. This existed already. So, you know, what a neat kind of body line to employ. I think it's going to need to roll up because we have to be at a height here that continues up to the point of the bow and then back down. But the point of the bow, we don't want to be in front of the people who are standing up there. So we've got some more measuring and figuring to do. But I'm thinking it's getting there. And I have to let everything that I build here tip into the floor. So we're going to have to come up with, when this comes down, if I'm half an inch or something, or an inch off the floor on that end, you know, what does that mean for a rigid hull bodywork? And then we're going to have to extend that with fabric or something that can crumple or otherwise, you know, push into the floor without being a problem with that. So that's coming down the pike. I've got to make plywood, three-sided, like star shape that puts these walls perfectly on the right angle, and apply it to the top so we can get rid of a bunch of this wiggle here relative to that wall to the other wall, and some other things here, so the whole thing can just get tightened up, locked down, more rigid. We've got the boat to construct. So here we talked about the model, and I'll make some modifications there, but I can talk a little bit about the boat over here. So I picked up a 3/4 inch sheet for the bottom and 2 1/4 inch sheets, but real plywood for the sides. Normally we call it Luan around here, which we shouldn't because it isn't. We use underlayment for like it used to be $15 and $18. Now it's like $22 a sheet. But now I got real plywood. This was $38 a sheet because it's hardwood. However, I just don't feel like gluing it together extra long and then cutting the shapes that we want and trying to get it to carry a curve. I mean, there's nothing else happening to make that boat shape other than the curve in those sidewalls. And if it has a crack or a break or gets kicked and it can't take that and it gets broken, all of a sudden it turns into a really hard and difficult thing for me to repair and make it look as nice as it ever looked. So we're just going to make an investment at the front end for that, and hopefully that will get us through. Also, the blocking from the bottom of the boat to the sidewall needs to be meaty enough to get a screw into it after I cut an angle on it, and it needs to be able to flex. And the meteor, I mean, a piece of wood wouldn't bend like this if it was this size. So I went with PVC, and I wanted something kind of chunky. And really the only PVC that isn't 3/4 inch thick is special order, or this is just brick mold. And so I think that this will do what I need it to connect to the floor and connect to the sidewall. And we may even, I'll probably use wood blocking in the other straight inside corners at the transom and at the bow. But the plastic, I think, is 10-foot sticks. And if I remember correctly, against the floor plan, if I get most of it, I get most of it. If there's an area that's missing, then, you know, no problem. And if it doesn't want to do the full bend altogether in one piece, maybe I could do it in 2 pieces. And in any case, we'll have what we need. I'm talking about going along in here, and if we have to use the second piece in there, we're going to try and use the full sheet, though. We're going to try to make a bigger boat. So yeah, if it doesn't want to do that whole thing, we'll have to be careful of that. Order of operations is going to come into play, though, because, you know, the question is, do I take the 3-inch or the 3/4 inch plywood and lay out what I think to scale this shape should be, and then put an angle on those plastic strips and lay them down as close as I can, and whenever I put them down where they will bend easily with the back angle, then I can work off of that and make a precise layout for the sidewall, where the length of that bottom edge is exactly the length that will meet up to this. I'm going to start being detail oriented, working to what it is that I'm actually making. So the problem with that is if I put the angle on it to get it to bend, to try and lay it down into a boat shape, to measure off of it to start making the actual full-size layout of the sidewall, I don't know what the sidewall angle is going to be to the floor at that point. I can get a little information off of this, but frankly, it's a more open angle on the back, and it becomes more closed as it goes around. It changes. So I'll probably end up putting a 45 on the plastic and calling it close enough, and it'll likely get construction adhesive down to the bottom and to the sidewall, and we'll pull things in with screws and let the adhesive harden, and not only adhere, but basically harden in the gap difference between the angle that I cut and the changing angle of the sidewall. So we're gonna have to play a little jazz with that. I'd also rather screw up through the plywood into that block that's laying on that curve. So how to put it there, hold it on a curve and get beneath it and screw up into it. It's a simple piece, but it's going to take some thinking. So we've got that coming down the pike for next week. So we've got the ability to rehearse all the tech and have all the set pieces functional as we're hoping to have them in the end. It's going to take some doing to get the stairs to connect to the ship and make the ship safe enough to be out on top of it. I ordered those gas springs, so they should arrive tomorrow or the next day. I think I just got the one for right now and see if I can make that one work. And if I like it, I'll get another one, or if I learn something from it and I need to get a different one, I haven't got two of the wrong thing, basically. So I'm just playing that by ear, but I have to make sure. That's why I like McMaster. Things come overnight usually, and we're getting down to having just a couple weeks. So we want to be wise and not put a decision off so late that you can't get what you decide on in a reasonable amount of time. The basking rock, I threw a bunch of weight in it, so now, even me, I can sit out here on it, and it only lifts off a little bit at the back, and I actually have to throw my entire ass into it to shove it down enough onto its wheels. And it's actually got me thinking that I'd like to use the larger size caster, which I didn't have any laying around, so we should get some more of those. I'd like to use the larger size caster. I think that would be a help. Once it's up and rolling, I think it'd be a help moving it. And there was something else I wanted to try and do. Well, in the end, I don't know if we need to put the fog machine in it, because we ended up over here against the stairs, and there's no other choreography, or there's nobody else using these stairs. So the fog machine could actually hang out there, probably downplay a little bit more, but that would have it work behind Ariel on her rock. And if we don't kill Ursula with this set piece and the fog machine in it, then this whole set, this could just stay here and live here. And instead, we'll move the fog machine out of here after Act 1 during our intermission, and we'll put it under a little, glorified mixing bowl, something big enough to actually cover the whole thing. But just a little, stone sticking out of the floor, basically, in Ursula's lair, that's there, without the fog machine in it throughout the first few scenes that you were in there in Act 1, and then come at the end of the show, and she steps over it, and the fog comes up through it, and ultimately she dies, but you don't realize that it's sitting there just for the fog machine. And I think that's a better way, perhaps, to do that. So what would that mean? It would mean we don't need to move the basking rock, and so then it could be built in. I see a lot of shows where something like this, to be stable and to stick up and look the way that it does, but not to move, they just screw it right into the stage. Or here, when we're out in the nice area of the stage, I could hook around underneath or behind there and attach, or otherwise lock in there. The problem that I have is that even though it's off to the side and it gets downplayed and we only use it when we need it, I really like that it can be taken away and brought back out. There's just something in me that likes, for whomever is impressed by the fact that people can go up and stand on this piece, or at least Ariel can, and it doesn't move or shake or do anything. But then in the next scene, it's completely gone. I just, I put a lot of time and effort into this. So we're going to continue to see whether or not it makes sense to modify our plans with this piece. But this is a process, like any of my projects, but this is a condensed version of any of my projects. It happens more quickly. The collaboration is, fast, and and very helpful, and we got to make changes, we got to learn. I like that about the project. So you want to remember that if you're doing something like this, that you don't want to get too locked in. There's flexibility here. And other than that, I think that's my weekend, so I guess we'll see you back here when I'm ready to actually execute some of these plans. So years ago, I was going to make a turntable, and I was going to make it the way that I prefer, where it would be the 3 walls on casters without a surface, just to clean things up, make it really nice to use. And so I employed like a propeller cut from plywood at the bottom and the top to control the relationship at the bottom and the top between this and the next and the next. For it to be applied to those, it will hold these angles and get rid of a lot of this, tons of that slop. We didn't end up using that turntable idea. It's one of the few times that I built something, got started building something, made those pieces at least, and then we went in a different direction because we ended up needing something different. So I set those plywood propellers aside because I knew that there had been a lot of time and energy in laying them out and making them, and that they'd come in handy for either literally a propeller or for the next time that I actually did want to make a turntable. Anyway, I needed one, and I've been looking and waiting for it to occur to me where it was put or how it was used or whatever else. And it's finally come down to the fact that I'm just going to have to make one to go on top of that. And so you need at least a 4-foot square if you're going to maximize all the time and energy, the longest possible arms on it for the greatest amount of control. So I had to find something. Luan's a little too light. 3/4 plywood would be a waste. So I was in the market for a 5/16/3/8 to a 5/8 scenario, even though 5/8 is kind of useful as a floor. Because the difference between Luan and something that you could use for a surface to walk on really doesn't need to exist. Luan works great for verticals. 5/8 works great for surfaces if you don't need 3/4 for something like that over there where I screwed right into the edge of stuff, or the rigidity in that is important. So we don't have a lot of 1/2 inch around. We did have this one piece, which is a hardwood veneer. It's got a stripe right there. It's I don't know, 1, 2, 3, not a lot of layers, I guess. It's a relatively nice sheet, but it's covered in staples, so I can pull them all out before I pick up and make what it is that I need. It's also got an extreme curve at this end, and the rest of it's laying flat. So really, I'd be better off making it out down there. But you know what? Maybe not. I'm really going to take practically nothing out of this sheet, even though I need it to, the whole volume of it is in this whole 4x4, but most of that won't be utilized. So there's something to be said for that little curve being on one of these legs that I make, not being that big of a deal. But the leftover pieces will be kind of unusable because they won't be flat. Whereas if I were to make it down here, the leftover pieces for whatever surface area there is, they're pretty flat, and the rest of the sheet that's complete, it's got that curve, but it could be screwed down enough in a different application that it would pull flat. So I'd probably be better off making this thing down at this end. And so I probably won't pull all the staples, but I'll pull everything from the middle over and then continue to lay it out and cut it out. Okay, I can lay out 120 degrees, no problem here. However, I started by going to 2 feet off the end of the sheet and 2 feet in from either side. And I forget that, geometrically speaking, if we're using this leg, and this leg, so get rid of those two, but those are the 3 that we need. You can see that this is the shortest aspect, and if I were able to move the whole thing over to where that interacted with that far side, the center would move, and I'd add length to this. And so what I'm basically saying is I need to show a 4x8 sheet in CAD and lay this out and move it around the sheet to understand what center point location maximizes my overall the piece that's possible to make. And so I guess it will actually, because such a wide angle, it's going to sit over, and one point will be in the corner, one point will actually be past the 4-foot line before this last bit is maximized or some such. So we'll discover what the situation is and come back and put the center point right where it needs to be and do the same layout off of it there, and then we'll have some confidence that we've got an equal length piece, 3 equal ends, and that it's the best use of this sheet. So I basically have to pause on this thing here. And so I had an opportunity when Julie showed up with some roller naps to get the glue out on one half of these 4x8 sheets of actual 1/4-inch ply, and so they've been overlapped and aligned, and I loaded them up with weight so that they can glue up to make a 12-foot long piece of 1/4-inch ply. I mean, obviously it's got the overlap in the middle where it's half, but we're going to try to make our sides of our rowboat out of that. And so I think what I'm going to do is set this sheet aside until I can come back with that CAD knowledge, and I'm going to pop the 3/4 sheet onto the workbench and see if I can't lay out the bottom of the boat using the model that I built the other day. So if the bottom of this model is a 4x8 sheet, I know that I can move in those degrees on either end here and try to get to there, etc. And I'm actually going to bend that plastic and see if it'll do it without having the angle cut on it, thereby reducing its cross section. See if it can do that bend, and if it can, I'll use it to draw the line that I mean to commit to, even though I'm not going to cut that plywood for a while probably. I want to make sure that the plastic will do the bend, and I'll probably leave it big like this to get the side to come in and attach to it, and then I'll probably maybe use the router and follow it from underneath to cut it off flush, or some such thing. But I think that it's only asking for trouble to cut that shape out and then hope to be able to utilize it. So we're going to keep the piece intact until then. But for now, I got to shift this off the bench and get that over here. All right, I want to resist making commitments until I've got a greater amount of confidence, or for as long as possible with a project like this. However, if I set up my T-bevel at the angle that this particular hull is, which is similar, I mean, I'm going to put a different shape on the top. I'm going to cut this down lower at, however, it fundamentally really doesn't change. This is it's a 2-dimensional curve that we're doing here. It seems 3D, but it's, well, it might be a twist, I guess would be 3D, but still, more accurately, it's a 2D situation. So the bow, for example, is at that same angle. Up here, on the side is at that same angle. And here, it's close enough, and we depart a little bit, we go more vertical at the back. So I can't change the angle that I slice into this along the way. However, I think that it would be ideal if the piece were to be open facing up. So if it's a more extreme angle, then once we put the bow together and I'm at the transom and stuff, and there's a gap at the top going down, I can actually backfill the gap with construction adhesive, as I was discussing. If it's too great of an angle, then the bottom is open and I can't actually see that to fill it. It'll sit tightly at the top, but then when you screw it in, it'll pull up into that negativity and twist the side all to pieces. So if anything, I want a block that's actually at a less extreme angle than the total angle that I might get. So I threw this, whatever it may be, onto the table just as a reference, and I know this is 90, and so if I pivot out of there, this reads 30 degrees. Almost exactly. Right here. It's almost exactly 30. And like I said, that was good at the bow all the way to about here, and then it starts straightening up more so. So if I wanted 30 is more extreme, maybe 20 is a nice balance. 20 may work at the back and then be open more along the way toward the front. In worst case scenario, I can actually send it through, unscrew it, and rip a greater angle on it and just peck away at that. So I think what I'm going to do as a result is I'm going to go put a 20-inch or a 20-degree rip on this. And I think it makes sense to do it where, and there's a glue channel on this, but the bottom is flat where the top isn't flat. And we want a greater amount of height over here anyway. We want to screw this down. So I think we're talking about putting this angle on right here. So that means we got to go set up the table saw and go from 90 to 70 degrees, or it's likely written right on that the other way around. So this would be 0, and that'll be 20 as far as the table saw is concerned. Anyway, we're taking 20 degrees off and we're leaving ourselves 70. We're taking the 20. We're leaving the 70. We're gonna establish that the degree, that the angle that we want to remove is 20, and we're gonna go down and set the saw to remove 20. And I hope that taking this closed cell and even this just a little bit more material off of this outside, that we're actually trying to stretch longer when we turn. I think that that will help because we expose the foamed PVC core that's in here, and in theory, all the openings from that foam can pull into an ellipse or stretch a little bit, where this has been sealed. It's smooth, and that surface now is resisting that bend. So it'll be less overall material cross-section by a little bit, and a completely relieved surface, and one step closer to what I think we need for a profile. And then I'll come back and see if I can't get it to more effectively bend the way that we need it to. This is what I wanted to know from CAD. That's just faster and easier. I gave these 3 lines the quality of being 120 degrees apart, and fully defining it isn't allowed, in case you're not really familiar with some of the software. So it's 120 here, but it won't let me click, or I can accept it, and it appears in parentheses. Anyway, so I gave those 3 lines that quality, and then delete. What's going on here? There. And then I gave that, and then there's a 96 by 48 inch rectangle here, and it's just centered on the origin in the space. So you can see where the halfway point of the sheet would be. And clearly we're beyond that, actually. So as I was saying before, in a 4-foot width, in a 4-foot square, I thought we would be making a circle first and then dividing it into the 3 pieces. But obviously, the more effective thing to do is to allow it to, I stuck this point to the edge of the sheet, and I stuck this point to this corner. And then I just tried, and this will maximize basically the lengths in the 3 equal arms of this thing. So I created a constraint that I used equal up here, and they're all going to stay the same length no matter what else happened here. And I sort of worked along at this until I had given it the information that I knew that I wanted, and it has shown that the location of the center point is 32 inches off of one side, making the arm length 32 inches maximum. And then if I try to find out from the end where the location is 27.71. So it's 27.75 would be fine. So 27.75 will move me off this edge a little bit, but actually that's fine, right? Because in the end, I've actually got to create, I had been thinking that I would create something like 5 that's 2x4 in width, like a propeller, like this. However, I believe that I am going to strengthen it and create a provision for the way that I plan to finish the turntable, in it being sort of like not a delta or like a Starfleet insignia thing, but I'm going to fill this area with a web and let that hang out. It's going to be even more strength, and I think the overall surface of each of the 3 sides, I want to get away from that body line going right down the middle at the back. The piece is a turntable. However, I don't think it's necessary whatsoever for it to be clearly 2 planes, and in fact, I hadn't planned to. I had planned to jump across it with organic kind of surfacing, so I can just push an arc in like that, and then I can give it the quality of being tangent to the line, which will move it out to that point, which goes beyond. So that's just a kind of a game. I have to bring that back into here. So it's tangent right there to the straight, and then this actually has to be on this line as well. And that's actually what I was getting at, is notice the center line of this component can be 32 right at the corner, but it actually ends up having to be shorter than that because that center line is constrained to the corner. So I actually might move this center away from the end in the amount that we were saying. It would have me showing this constraint and deleting that and deleting that. Well, these are the qualities of that point, and there's various constraints there. So I've deleted it there. Okay. So now I can actually, it's going to blow this thing to pieces. So you have to be careful the order that you use here, but now everything's purple. I can tell it isn't locked down in space. So I can drive, it'll let me make this dimension, and I can actually drive it over a couple of inches. Let's go to an even 30 inches. Oh, it did work. Okay. So if we go to an even 30, obviously I can't get much longer than this, but I can square that out. And then this radius, I'll just do this with a bendable ruler. I'm just showing it in the computer to truly be tangent there, but I'll just eyeball that, no problem, and we'll do it over here and we'll do it over there. So at 30 inches from the end and 32 inches from one long side, I can put a center point. I can create 3 lines with 120 degrees apart from one another. Then I can offset 1.5 inches from either direction, so I got the 3.5 inch thickness of the flat, and then I can just bend a curved ruler in the 3 areas and scribe that line, and then just zoop it out of the sheet. It is going to consume more than that 1/2 of that 1/2 inch sheet, but that's fine. And then I'm glad that I basically did it this way. And actually I can finish this sketch, and I think I can print this. File, print. It's going to take some doing here. This normally doesn't look at like that. And actually we'll just screen grab that file, or just export an image in a Little Mermaid, and we'll call it the turntable gusset. Save, and then I can just print that image. So if I go into active projects and I go into Little Mermaid and I go into turntable gusset, there's the image of the screen, and then I can just print this and take it with me. I think that's right. It's 4 inches longer, 1 inch longer, or 4 inches in full scale at the bow, this dimension across that, than that which is on the other side. So you can see there's about an inch difference here, where 1/4 inch is a full inch. That's 4 inches greater. And at the back, instead of continuing to a higher point, it went to what was supposed to be just about the same dimension there. And I think that fixes and really makes a nice boat. So I can literally scale up these dimensions. I made a note here that my halfway point between this point and that point, the greatest dimension at that is at that point, because this is an arc, piece of a circle, and it's 7.5 inches from the full sheet. So I can find the rest of these points. These 2 points are on a right corner. Sorry. Hang on. These 2 points will be on the right corner of the sheet, and then at this location that I left onto the pattern, it's 7.5 from the straight side. Then there's this point. Then there's this angle, which is also whatever dimension this is off of a square sheet. You'll see how I lay this out. And I'm going to try and do that and still get 2 pieces out of this 4 foot wide width, which is going to be the main factor there. I feel like I should be able to do it. One's going to be at the one end, one's going to be at the other, which I think is going to give that seam will end up facing the bow and facing the stern, respectively. Maybe not, because I think there's only one way to put 2 pieces on this size and get them out of it, as well as being able to lay them out based on the outside factory edges of the sheet. And so that's what I'm going to do. And then we'll see if they end up with the same seam in the same place on both. I think they might. Although the overall shape is shorter than these sheets together. So I'm going to start at one end, and then I won't start necessarily at the other end. I'll start just far enough away so that I can tuck them in together. You'll see. Okay, I put the cardboard back together with the negative that came out from around it because it's actually easier with cardboard. When you go to these points, they just mush in when you try to pull a dimension on that. So I like to look at also the negative that came off of there, and as it's square too. So it gives me a sense of, that's the corner that I have, and unless I've got it in negative, I can't make an assessment there. So the measurement from here to here, and the measurement from here to here is then connected to create the aspect of the piece that we want. So again, having that, then I put that on here. So here it is, quarter scale and full scale. And down there I found, this distance here, once again, pulling tape between this point and this point, more effective than pulling from these points, which are ultimately 2 pieces of paper. And that's something where if I had used 1/4-inch plywood or something, a little bit more, take a little more time, maybe not. It's not something that travels well. So setting up next to the bandsaw it would require that. Anyway, now I went out and put that 7.5-inch cord, because of course this isn't the center of this piece of a circle. The center of that piece of a circle is over there somewhere. So it's a cord that we've got here, line from one part of the circle to the other part of the circle. If this edge of the sheet is that line, and that line doesn't go through the center point of the circle, that's a chord. And it's also an arc that we're trying to show here. So anyway, I went to the center point of this, to that point down there, pulled the 7.5, and then added these blocks to help that plastic stick stay in place here. And then I put the actual point to point marks on that stick, but then I took it out and I brought it over here. Because we got to remember that while I like the way that pattern piece looked, and so much of that is fairly accurate on the side of the boat, it relates to the bottom of the boat. So I got a center line on this full 4x8 sheet. However, the actual point of the bow is like 1 inch in from the sheet. And over here, this is the piece of plastic that came over here, if this is the halfway point of the sheet, we are probably 2 inches in from there. But on the model, is that exactly the case of where this piece is? Because I believe the curve on the bottom of this is exactly the same as the one essentially that we made, because we traced that and kept that part. So it looks like the bow on this ship is a little light of 1 inch inside the end of the sheet, but over here maybe 1 inch, 1.5 inches from the edge of this plywood, and our dimensions at the back are the same. So it is fairly freaking close. But I'd rather not just assume that and allow that to be blown up separately in 2 different pieces from a scale model. I want to pivot right now to working between the 2 real life pieces, see if I can't make them fit even better. And so there's a variety of ways that I could do that. I'm basically checking to see if the length of that arc is anything like the length of this arc. And I guess the comparison will be made from where it crosses over the center line, which is basically here. Now that's at an angle, and there are other geometric complications here. That's where it crosses the center. And we're not going to get that detailed with them. And then there is, I don't know where that chunk came out of. Maybe the first time it leapt out of here because there's a lot of tension. This back here is where the outside of the transom should be. Like, this kind of takes into account the thickness of the plywood. So I guess we're trying to get it to come back to the back edge of this ply, because the transom will come down and sit on top of that and probably not be applied to this edge. It'll probably be a thickness that stops onto here. So if we're going to zoop down in there and then it's going to tip back at an angle, that means that the actual sheet is kind of like the perfect dimension. Now we may leave the things a little bit long, but say that was where the right place started. If I measure along this curve, and that's part of making sure that they work together at 90 degrees or some type of serious angle to one another and have any relevance, that distance they basically share. So we have to make it the same. How do I measure that? I'll probably get my chalk line out and pull the string from here to there, and then I'll lay the string out flat on a tape measure and see what the length of it is, and then check that versus this, and then try to make some modifications to bring them into some sort of harmony. In fact, the easier thing to do, probably leave this right in place and take this back, bend it into position, and simply, you know, have plotted on it where if it's a shorter dimension or practically even longer, and just basically remark the sheet up or down from whatever degree needs to change. And then, you know, is the question of if it's a bit shorter or longer, do I simply reconnect that to that point? Because I don't think I can. That angle brings the plane of this bow join right through the plane, the perfectly vertical plane of this bisecting line at 90 degrees from the floor plane. If you were to back that up at the bottom, it would kick this angle out, and you'd have to thereby, or if it was longer, it would change this angle. It changes that. So let's just cross that bridge when we come to it, I guess. Okay, I carefully got a string that I could be sure came from that exact point and didn't slide underneath. I had to add a couple screws to hold this down, but it was in that inside corner to this exact point right here. And that string, I came over here and pulled on the edge of my sheet actually and just scrubbed it, and that's 101 inches long. So that means that point to point on there is 101 inches. Then I came over here and I put my tape on this one mark at 101. And I come down here and I see that essentially, if that's an inch, I need about, I'm off by about an inch, which comes from blowing up corrugated cardboard with tricky geometry that has some sharp points that are kind of floppy. That's a pretty good amount of error, or an acceptable tolerance to have of 1 inch. So if I were to go to 102, with that, I could keep my current layout and I could put this thing back in with those blocks, and basically I didn't trace it, but I could strike that and I could keep moving. So I could either keep this 102 and modify this, which if I wanted to add an inch over this distance here, I'm pretty sure I could just unpin this and let it jump over to where it intersect the actual center line coming off the sheet, and that'll be what I need with that. Part of me wants to avoid that because it's a point and it's nice to keep something like that cut within everything. But to another situation, you could look at it, it really doesn't make any difference. So I'm struggling with the best practice there more than anything at all. Alternatively, I could leave that right where it is, because I wanted the sheet, I'm thinking, to stop on this surface and stop on this surface and have registration around the corner, which I guess it will, because the last thing I'm going to do is going to cut that away. So it would stop here and there, and it would make an interesting, about that little tiny bit larger. And obviously my other option is to simply squeeze an inch out of this. But then, like I said, it changes what that angle should be. And so I'd have to try, my first thought was, well, you have to make that change to this here and then refine the angle, but then you kind of need the two pieces to be, I don't know. I'd rather not monkey with that. So I think that I'm going to, in fact, leave that right alone, but also stick with this, lay it out and cut it out, take it over there and see how it fits on that, and essentially try to prove out that I would need to, move this over a little bit to be theoretically perfect intersection of geometries, and just see what happens. It may be clear that will be the case. It may become relevant that I didn't even have to do that. So I'm just going to hold off, but I think the way that I'll fix a discrepancy will be in letting go here and just moving over a little bit, taking more of the full sheet of 3/4 inch material and pressing forward without risking that the geometry come together at the bow in a digestible way. I may be making up a problem there that doesn't exist, but I'm just going with my gut. So I'll take this back and scribe it and lay that piece out, and then probably cut that out and trace it, rather laying out another one completely, mostly because it's the best practice at a smaller scale, so I guess I'll do it that way on big scale too. And there's no benefit into laying them out both by hand just to see them and then cut the sheet. Although I guess so, yeah, because my point is, can I get both out of here, or will that become something I need to modify them a little bit just to be able to get them out of the material that I made? Well, let's lay one out first and then. All right, those came out back to back as mirror images on that sheet, so the seams can be mirror images of one another. And so I don't want to actually put it together as I've done here, despite the fact that my tape has already let go, so that the seam is forward facing on the bow. I want it the other way around. So I got to remember to turn those inside out from there. But the area that got glued is now 1/2-inch plywood basically. And I glued it up flat. And I suppose I could have tried to glue it up on a curve, but all the processing that's come afterward would have been a bear. So being glued up flat and now twice as thick, that area really struggles to do this bend, although I think it ultimately will do it. I think what I need to do is make the transom based on the model, at the scale model, and then probably move this to there as a, and then cut it off lined up with this center line of the sheet, as well as cutting, I think, this back 3/4 of an inch, but at an angle for the transom that'll be made of 3/4 inch. So I might just wait until I've got that angle and yada yada. But anyway, get it to a point where both ends of this have been trimmed and its mate has been laid out and perfectly symmetrically applied to this sheet of plywood. And then tape on either side of the bow, like I did already a little bit, but a little more, and attach the two sides to the transom piece, and then bring it over here and try to, I guess, hook and sneak down tightly on the bow to the point where the transom's sitting up down here. But I could potentially make a few screws, or at least 1 or 2 screws in there. Yeah, make like a screw in on the inside of the point, and then let go of the transom enough to get the sides out and around these undercut edges, and then try to put it back together again, and basically just dial it as all 3 pieces of the hull and all 3 pieces of the base kind of made as closely to spec and so that they should work together as possible, and try to have it all happen. I talked a big game about taking these things in steps. However, at this point, I might have done that much and put the other piece on here and done all that yesterday, where I said I was going to hold off until I got somewhere with making those, but you just don't know. And so anybody using this as a guide now to make 3 sheets of plywood and 2 sticks of PVC brick mold rowboat set piece or something, if that's what you're here to do, learn from me, I guess, and you can move through this with confidence if you're careful. Well, let's make sure that I actually get it to work first, right? Let's not get ahead of ourselves. So I'm tripping through a small problem, but I like to keep all of the Torx drive screws that I use T25, and you start getting into T20 or T15 or something else like that, and it becomes super annoying to have to change bits or have several screw guns going. T25 all the way, and you ought to be able to have everything from 1.25 inches long to 5 or even 6 inch long. In fact, even 1/4 inch heavy duty I bought recently. Where are they? Here, from GRK, to replace the legs that we're holding the wheels on with. These short babies here, like I said, I twist the head off periodically, and they really shouldn't be continue to be reused. These are going to have far more structural integrity and engineering, and they're T25, so I haven't got to get sockets and wrenches or any other BS going, and they, you know, can be screwed right in quite effectively, and they cut their own way, unlike those which are, like I said, more annoying. So in trying to stick with T25, Lowe's has changed in the past year or so who they deal with in terms of all their different construction screws. I forget who they used to have. However, the lengths I can have are 1.5 or 2, but no 1 5/8 or 1 3/4, at least at this Lowe's. So anyway, 1.5 inches isn't quite enough. It's only about 1/4 inch or 3/8 into this material, and then 2 inch comes through and sticks down. And like I said, I need enough holding power against this arch. So I have the 2 inch screws in, which are all of them coming through the bottom. And so I replaced them, I think, on this side with the 1.5 inch once. And once I had all of them placed and they're all holding the curve, then it's easier to just rely on the shorter screw. But initially screwing in there to hold it, it's ripping them out or causing them to strip. So it's just kind of super annoying, unwelcome problem to have in a project like this one right now. Anyway, so you want to pay attention to every little thing here. Ideally, you'd have 1 5/8 screw length for this application right here. So that being said, these are symmetrically applied to this, and now all I really need to do is to make the transom, and I'll make it so that the dimension at the bottom of the trapezoid that it is exactly from here to there, which should be 48 minus 20, which is 28 exactly, but we'll be sure of that. And then, you know, we'll look at the model and see what that upper dimension kind of should be and the overall height of it. And we got to figure out the angle that it's at. So we got to pull that off, this angle. And then we've got to make a piece with that angle on the bottom and yada yada, all out of 3/4. And then we've got to cut the ends of these back. Now these could just be cut back a bit farther than that. Nothing has to like necessarily intersect. Even the point, you know, I bothered to, it will be nice to have that material, don't get me wrong. And that's, you know, that's kind of, so you can live without this. They can just stop short if you don't feel like doing that. In fact, I'm having a little bit of a kerf thing here that I don't exactly mind. The lower point is right at the edge of the sheet like I wanted. So it'll be nice to have this meat to screw into here. And so at the back, I will bother to make that slide right into there because I'll be able to screw into that as well to hold it. And I'll probably, you know, I've been trying to avoid gluing this because as cool as it would be to have a boat on wheels around, it's not necessarily all that often that you need it. I don't know. There's a lot of plywood in the bottom of it, but in the sides, there's really only one use for those, and it's been had now, you know. So maybe I shouldn't be so concerned about using glue and just turning this into a boat with a flat bottom. I mean, I guess there's probably enough of a use for it. Because you've got it, then you can add to the production value of various shows going down the road with a simple boat that can be made to look like it's from any era and is, you know, at the end, it's only 2 feet kind of thick and would stand up and it's relatively light. So yeah, I guess we may glue and therefore it would be all glued together. So yeah, I'm wrestling with all these things. I'm doing this for the first time, and you know, it's always way easier to do something just the very next time. So again, anybody looking to make something like this benefit from my learning curve on this, I'm trying to be forthcoming about it, but I think that's my next move, is to make that transom and to put it on here, or at least to cut this back ready to install. Oh yeah, I'm going to put it in between the two sides. So make it and put it in over there, and then cut for it to be here, or maybe wait and hook this and see where that falls on the back, just for comparison's sake, just being careful. So yeah, let's make the transom and then put it in to the two sides over there. Well, I ended up pulling 22.5 degrees as that transom angle, which is a common construction angle. It's half of 45, right? So that's what I put the bottom edge at, and then I realized, well, that would make the top level if it had the same angle on it. That's what I've got here. And then I came, I started thinking too that the sides are closing in as we go by here. So rather than being 90 degrees here where it would kick out and fight that, I thought 22.5 sounded pretty close, and it ended up being practically ideal to have all the way around this transom. So it's undercut 3 sides, bottom and the 2 sides, and then it's the other way around on the top to make it level or to create a rhombus where that angle is going right in both cases. It's a parallel sides, top and bottom. So that being said, then I needed to, because of kerf, stupidly, I ended up losing, and I needed to squeeze these pieces in from here to there and from here to there. So I actually had a half of an inch that I lost somehow, but not, I don't think, a big deal necessarily. I think everything's going to play to the back here, and then whatever excess or anything, that there is, the back can be influshed one way or another. So we're going to hook onto the bow nose and play our way down here, and when we get here, we'll iron everything out at the back, which is the best place to do it anyway. So we've been careful to this point. I think now, noting that angle, that would mean that if I were to make a block of wood here to run along this and to be more supportive of that luan, it would have a 22.5 degree amount of material removed from it, that angle cut off of it. Same on the other side. And then, the question is, then I could take it over and I could put it between the back of those and really connect it in there really nicely. Will it have to be loosened and redone in as I get this situated? Probably. At the front, I think that this angle would be true all the way through the bow. And so that is, whatever that is, go to there, and it's hard because it's a curve, but suffice to say that 65, I don't know, 70 I don't think is right. I think it's straight enough to say that 65, which is to say to set the saw 75, 85, and 90 is 25 degrees using the when you use the square this way and you align this to an edge, which I could do here, and it'll say 25, which I could have done too. So so 25 ripped off of a stick would work in the bow. So I could make myself that stick and put the bow together like with robust kind of strength, and I could make 2 sticks at 22.5 that are about as long as the side of the transom and add to it and put that in there. And so that's actually quite a nice, pretty strong shape where the sides are trying to be straight still. Well, they're going to bow to some extent, right? And then I come in here and hook on this and then try to sit the rear end down carefully. One last thing, I think I'm going to take these white, like gunnel, not really, but these bars off, and I traced them, and I retraced the new location here, so I got to remember that. But I think that if I set my jigsaw angle to 22.5, or what did I put on the side of this? That's actually going to go back to whatever this is, 20? I think it's 20. Set my jigsaw angle to 20 and cut that line. Then I put them back on, pulling into the same screw holes, and actually the edge of this plywood will go in at an angle, and that'll actually take the overall footprint and shrink it, 1/4 of an inch all the way around, or 1/2 inch total. So that will make it all that much easier for this to sit. Once those pieces over there are sitting there kind of boat-esque into space, this has actually got a draft angle all the way around, so I could bring it over and set it in and use gravity to kind of push it down, walk around in there, and it should shove those sides out and kind of fit almost perfectly. If anything, it'll be a little bit loose because of some of these things, like I said, that being smaller. I had been planning and measuring, and we noted the length of this at this elevation, but when we shrink it down some, should smoothly go down into that boat. And then it'll become a question of maybe I'll open up a gap at the back and kind of push it, shoving it, tucking it into this shape and cinching it all up tightly by blocking it in, cinching it like it's being able to squeeze edgeways. It'll almost kind of be ideal, I'm thinking. And then attach it. And I'll have a real nice amount of meat between the thickness here and the thickness of that. I'd probably still try to get into the plastic instead, but that's so much the better. And let's see if we can't make a shape. And then it's 1, 2, 3 wheel locations, but I'm getting ahead of myself. Let's take this stuff off, cut that carefully with the jigsaw. The jigsaw is strafing. It's not holding blades at perfectly straight ahead, it seems like. And it seems like it's listing. It seems like it's bearing left. It's hard to see. It seems like it's tipped that way a little bit. It just felt that way. So anyway, I don't want to mess this thing up if I can help it. Although everything that I'm doing is going to be covered up with those pieces there. So I'm just trying to use best practices here. Let's just shut them up and take those off, cut and put them back on. Try to put that transom into those pieces, make those blocks.